different types of work we know. So first we will see work done by a force may be positive, negative, or zero. So all the three cases we can have. So first we will discuss the positive work. So in what case we have the positive work? When the component of force or force is parallel to displacement. Parallel to displacement means in the direction of displacement, means the angle theta between force and displacement is less than 90. Okay, so I can show you with diagram. You can see that if you see the force, the component of force, this is not exactly parallel, the force is not exactly parallel to it. If you see the component of force, the component of force is what? If you draw a perpendicular, the component of force is this much. This much is the component of force. So if this is the component of force, then if this is the component of force, then this is what? Parallel to S. So this will, the work will be positive in this case. And in many of the cases, we will see when it is negative, that also we'll see when force is anti-parallel, then it is negative. So the positive work signifies, what positive work signifies? That the force or external force favors the motion of the body. You can see the component of force is in the direction of displacement. So the force is favoring the motion. The positive work signifies that external force favors the motion of the body. Okay, so this is the meaning of positive work. Okay, next we will see examples for positive work. When a person lifts a body from ground, the work done by lifting force is positive. Since he is lifting an object, he is applying the force in upward direction. The force by the man is in upward direction and displacement is also in upward direction. So work done by lifting force is positive. When a spring is stretched, the work done by external force is positive. So if you suppose you are stretching a spring, so if you are stretching it in rightward direction, the displacement is also in rightward direction. So force and displacement are in along the same direction. So you will have positive work by the force. Okay. Next we see if displacement is exactly in the same direction of force, the work done is maximum. So exactly in the same direction of force means what? They are parallel, exactly parallel. So theta is 0. So Fs cos theta means what? Cos 0. So what you are getting is F into S. So when the angle between them is 0, the force and displacement are exactly along same direction, the work done is having maximum value. Now we will see negative work. So in what cases we have negative work? You can see the diagram. The negative work means that force or component of force is opposite to displacement. So you can see the force is like this, means it is making angle greater than 90 and less than 180. So component of force, you can see it is in backward direction. It is in opposite direction of displacement. The angle theta between force and displacement is greater than 90 and less than 180. So obtuse angle. Okay. So in this case, we have negative work. And what it signifies? It signifies that external force opposes the motion of body. You can see the body is moving forward, but the component of force is trying to resist this motion. So the negative work signifies that external force opposes the motion of body. Okay, so next we will see some examples. So the same example, if you see, the person is lifting the object upward. So in this case, the gravity is acting downward. Gravity is always downward. Gravity is what? Downward mg. So the displacement is upward, but gravity is downward. So the work done by gravity is negative. Okay. And in last case, when we saw positive work, the work done was work done by force by man. This time it is by gravity. So I can show you. See, in the last case, in this one, this is the work done by lifting force, the work done by man. Okay, the work done by man is positive. But in this case, you can see The work done by gravity is given. The work done by gravity is negative. Okay, so gravity is acting downward and displacement is upward. So in the same situation, one force is giving positive work and another force is giving negative work. The gravity is giving negative work and the man is giving positive work. Okay, now look at the second example. When a body is made to slide over a rough surface, the work done by friction is negative. So suppose this object is sliding forward, so displacement is forward, the friction is backward. So they are in opposite direction. So work done is negative. Okay, so this is the example of negative force. Okay. Now we can see if the displacement is exactly in the opposite direction of force, the work done is having maximum magnitude with negative value. Okay, so that you can see that work is, so theta is 180 degree. So work is Fs cos theta. So that we can write cos 180 is -1. So minus Fs. So you will have the maximum magnitude of work, but with negative value. Okay, next we will see zero work. So what is zero work? So zero work you can have under three different conditions. So if you see the equation of force, what was that? It was Fs, equation of work. It was Fs cos theta. So if the angle between F and S is 90 degree, then cos 90 is what? 0. So work done will be 0. So this is the first condition or one of the case. If the force is perpendicular to displacement, then the work is 0. Okay. Cos 90 is 0, so work will be 0. So we will see the examples. Cos 90 is 0, so work is 0. We will see the examples. So this is a very common example. If an object is moving in circular motion, the force, centripetal force, act towards the center, and displacement is like this. Okay, so these two are perpendicular. So force and displacement are perpendicular to each other. If they are perpendicular, means the work will be 0. The angle between them is 90 degree. Second condition is when the displacement is 0, means the object is not moving at all. If the object is not moving, there will be no work done. So the best example is a person trying to push a wall. So if you try to push a wall, the wall will not move. So if the wall will not move, the displacement will be 0. And if displacement is 0, the work will be 0. Okay. So this is the another condition. Okay. Now we will see the third condition. If there is no force acting, so if there is no force acting, there will be no work done because the F itself is 0. So the best example is if a body is moving with uniform velocity on a horizontal frictionless surface. If an object is moving on a horizontal frictionless surface with constant velocity, then there is no force which is giving some displacement, which is acting in the direction of displacement. So force is 0, so work is 0. Since there is no force, so there is no work. Okay. Next is, okay, next we will see work by various methods. Various methods. Okay. So how do you find work with different methods? So work done by constant force. So that we have already seen. For constant force, we can write simply F into S if it is vector form. If it is not vector, simply you can write F into S. No need to write vector. Okay, so for constant force, you can write directly like this. Next, we will see variable force. So constant force we have already discussed. So main thing is variable force. So if a force is variable, then how do we find the work done? So for work done, we have to write in this form. The force is function of x. So F x, this means the function of x. Okay, F bracket x is function of x. So the work will be force into displacement. For a small displacement dx, the force into dx, and then we have to integrate it to get the total work. So F into dx, and from whatever initial point xi to final point xf, we have to integrate. So we will see an example. Okay. Now we will see the examples for this. See, we will see example for variable force. Okay, so for before that, we can also see the graphical representation of the work. Okay, so if we have Fs graph, suppose we have force and displacement graph. So force and displacement graph. What does it mean? Force and displacement graph means what? If you consider the integration f ds, so what is this? Is this area under the graph? So integration of f with respect to x will give area under the graph, and that is also the integration is also work. So we can say that work is area under fs graph. So area under fs graph is equal to value of work by the force. Okay. So you can also calculate the work with the help of graph. And now if the force is constant, if the force is constant, the F is constant and S is here. So you can simply write this area is the work. So force is constant. So F into displacement. The F is height and displacement. So F into S will be the work done for constant force.